So I'm going to summarize what y'all basically read, okay? So we have, when y is all by itself, it's called explicit form. But when you have a standard form, meaning all the variables on one side and the whole number on the other, that's called the implicit form. And I know you read all this and you were like, I have no idea what I'm reading, right? So I'm going to kind of summarize what is happening, basically. So on the very bottom, I want you to write out 1, 2, and 3. Step 1. So far, we have been deriving everything with x's. Today, we're going to derive something with the y's. So when I derive something with the y, you have to always, at the end, multiply by dy over dx. And it'll all make sense once we're done with the first question. Step number 2, you're going to factor out dy over dx. Factor out dy over dx. And step 3, we are then going to divide it by the whole chunk. So really, in the end, the only part that we're doing calculus is the first step, okay? Everything else, we're factoring and dividing. That's algebra 1. Everyone good with that? Okay? So again, line 1 is the only calculus part, okay? So here we go. Let's see. So we have dy over dx means to find the derivative, which is our differentiation, correct? Okay? Let's kind of remember the other notation. The other notation was f prime of x. And if I give it to you in terms of y, what do we say? Just y prime, okay? They all mean the exact same thing. So here we go. So on this one, I think I'm going to erase something. Boom. Okay. So the way I'm going to read this, it's going to be, it'd be nice if I have a color right there. We have derivative of the given function with respect to x. And that is how you read it, okay? So let's go ahead and derive each part. So my first part, when I derive this y cubed, we bring what to the front? 3 to the front. And 1 less of that power is squared. So if I'm deriving something with the y, our step number 1 says, now say times what? dy over dx. Because if I don't say that, our second step is not going to happen, because second step says, now factor out dy over dx. Okay? The next one. What is our derivative of x cubed? Plus 3x squared. That was not a y piece. We're going to leave it as it is. The next one. Negative y squared. That's going to give us minus what? Minus 2y. So then I derive something with the y value. So we need what? dy over dx. The next one. Derivative of negative 5y is simply minus 5. And again, that was a y piece. So what do I need? dy over dx. So anytime you change something with the y, we're going to tag along dy over dx. My next one, negative x squared is what? Minus 2x. And we know derivative of any constant is always what number? 0. This is the only calculus part that we've been doing so far. Okay? Everything else is going to be algebra 1. So here I go. I am going to box everything that's got dy over dx. So here I have dy over dx. Here I have another one, because I want to factor, because factor means we have a common value. And I have another dy over dx. So let's go ahead and factor that out. So I'm going to bring out dy over dx. And then write the remaining inside the parentheses. So my first one, 3y squared. My second one, what do I put back? Minus 2y. And my third one, I'm going to put back inside the parentheses minus what? 5. Isn't that applying algebra 1? Okay, factoring. And then I'm going to do something else because I want to write less. So I'm kind of being lazy in a way. So here I go. What I want to do next is going to be, I think I want to bring this one to the other side by subtracting, and bring this one to the other side by subtracting. Isn't that algebra 1 again? Okay, so here I go. Is equal to negative 3x squared minus 2x. If you want to take the extra steps, go for it. Okay? Now look at the box. Step number 3. Oh, I made a mistake. Where's my mistake? Plus 2x. Silly me. I can't do algebra. Okay, our last step says now divided by the whole chunk, right? Isn't my whole chunk right here, basically? This is my whole chunk. We're going to divide it by it. Normally, I wouldn't write the whole value, but I'm going to this one time. So dy over dx. And I'm going to keep the top as it is and divide it by the whole chunk that I've circled. So it's going to feel like you're copying quite a bit, which is fine. And that is your slope function. So let's write, this is our slope function. Okay, so then I'm going to prove something to you guys as to how this is going to work out. Okay, we have that ugly picture, right? I'm not expecting you to know that all that function is basically creating this equation. I want you to write something out off to the side. If I tell you I have 1.5 comma 2.2-ish, so I'm going to say this right here is my 1.5 comma 2.2. That's my x and y. When I plug that into my slope function, meaning anywhere I see an x, I plug in 1.5. Anywhere I see a y, we plug in 2.2. You're going to actually get this result. Your slope is going to equal negative 0.7. And if I were to make my slope or tangent line, isn't that pretty much going down? Yeah? So this right here is my slope at 1.5 comma 2.2. Are we good on that? Okay? So you can calculate that at any point. Good? All right. Let's go on to the back. On the back, let's go ahead and derive. And I'm going to erase that thing again. Okay. So let's read this correctly. We are going to derive this function with respect to what? X. And I'm going to rewrite something because I see a product rule right here. This right here, let's all write it as 2x to the power of 6 and 1y to the power of 9. So then that way it's cleanly separated for us to use product rule. So here we go. Let's kind of recall product rule. Do I derive first or keep first? We derive. What is the derivative of this guy over here? 12x to the power of what? 5. And then I keep the next one. So I'm going to say y to the power of 9. And then what was our operation separating our two left and right chunk? Plus sign. And then I keep the first one, and we derive the next one. Kaden, what is the derivative of 1y to the 9?
9y to the power of 8.
Yep, 9y to the power of 8. Now, we just changed the y value, correct? So what do I need? dy over dx. Now, let's derive the next one. Okay, Kyle, what's the derivative of positive 3x? Just 3. Okay, Brady, what about negative 1y to the power of 3?
Negative 3y squared.
And then, what else do I need to add?
dy.
dy over dx. Very good. And then our derivative of any constant is how many? 0. And again, line 1 is the only calculus piece. Okay? So I'm going to start boxing some things to organize. So anywhere I see dy over dx, I'm going to box it. Here's one over here, and here's another one over here. So our step number 2 says now factor out the what? dy over dx. So I'm going to write dy over dx right here. And while I'm factoring, I think I want to do two things at the same time. What is 2 times 9? 18. So we have 18 x to the power of 6, y to the power of 8. And then on our next one, I'm just going to copy my minus 3, y to the power of 2. And while I'm at it, let's go ahead and move the other pieces. I'm going to move this to the other side by subtracting. And then I'm going to move the positive 3 by doing what on both sides? Also, subtracting. So we have minus 12 x to the power of 5. That's a 5. It's not any better. Y to the power of 9 and minus 3. Is everyone good on that so far? Step number 3 says now divided by what? The whole chunk. This whole chunk. I guess I'll write it. But I won't say anything about it. Y'all know how to copy what's on the top. All right, so far so good? All right, part B, Santiago, let's read. It says to find what?
The slope of the curve at 0, -2.
Okay, this is very doable. When I give you a value of 0, isn't that very easy, basically? Okay, so let's plug in. Anywhere I see an x, I'm going to plug in 0. Anywhere I see a y, I'm going to plug in -2. Let's do that together. I'm going to do it right here. So we have -12 times 0 to the power of 5, minus 2 to the power of 9, minus 3 on top. 18 times 0 to the power of 6, times -2 to the power of 8, minus 3 times -2 to the power of 2. Okay, let's see why this is going to be really easy in the end. What is all that chunk going to give me? 0. What about all of this? 0. So that tells me I have -3. So when I compute, all this is going to give me negative what number, somebody? -12. And if you're like, why is there a -12 when I see two negatives? You square the -2, which is 4, and then you multiply by -3, which is then -12. Are we good on that? And then when I further simplify, that's going to give me 1/4. So let's see if that is true according to our graph. So everyone go to your graph and plot 0, -2 right here. It looks like the slope is flat, but do y'all see that it's kind of slanted? So it's kind of slanted in this manner. And that will be 1/4. That is our slope. At 0, -2, it is 1/4. Are we good on that? Okay? All right. So we have 2 more. Actually, before our 2 more, we have one more thing. Okay, Kyle, let's read 2C.
What's the equation of the tangent line at point 0, 2?
All right, equation of a tangent line. So this goes back to unit 1. Let's see if y'all remember. Given a point, that's my x1 and what? y1. And then we know our slope that we just found was what? 1/4. And then let's recall our formula. It was y minus y1 is equal to what? M times x minus x1. Very good. And then we have y plus 2 is equal to 1/2. And then x minus 0, although we don't need all that, right? If you want to make this into y-intercept form, it's going to give us 1/4 x minus 2. On the AP test, they're both good. So if it bothers you that that we are multiplying by 0, go all the way down, but you don't have to. Good? Okay. So we did chain rule last time, right? Let's practice that real quick. So here we go. Let me erase my 3. Boop, gone. Okay. This becomes chain rule because inside I have 2y, and at some point I have to apply the chain rule, derive first, and then go inside, correct? So let's go ahead and practice this real quick. And let's read this correctly, because it's going to be derivative with respect to what? X. So here we go. Let's see. Sloan, what was the derivative of cosine? Negative sign. And do I derive the inside right now or keep? We keep. We derive in layers. And then Darius, when I then derive what's in the inside, what is our value? 2. And because I just derived something with the y, what do I need? dy over dx. Okay, Maggie, what's the derivative of 1x?
1.
Just 1. And we're solving for dy over dx. So I'm making this one by itself by simply dividing. And I'm going to give you the better answer on this one. -1 times 2 is what? That's going to be the coefficient that's going to go in the front. So my final answer that I like better is 1 all over -2 sine of 2y. That's a y. Again, avoid doing this because some people might. Do not multiply these 2's, okay? They're not together. The sign and the argument, they're stuck together. Since we all like to make up math. All right. Okay, let's recall our second derivative notation. I want you to write y prime is the same thing as dy over dx. Y double prime is the same thing as, let's see if y'all remember from unit 1. I think beginning of unit 2. It was d squared y over what? Dx squared. Okay, and again, that notation we didn't make up. We just have to go with it. Okay. So our last question then. How many times am I asking you to derive on number 4? Twice. Okay? Let's talk about something unique about this function. If you were in geometry, you should know. If you were in pre-cal during the conic section, you should also know. This is the shape of a what? It is a circle. Okay? Something unique happens when we derive a circle. So for this one, the circle is centered at 0, 0. What is the radius? 5. Okay? No matter where the center is or no matter where the what the radius might be, our slope function will always be the same. So I'm going to prove that to you. So here I go. Let's go ahead and derive this with respect to who? X. So here we go. Indicate what's the derivative of 1x squared? 2x, very good. Okay, Oscar, what's the derivative of 1y squared?
2y.
2y. Now, because I've derived something with the y, what do I need at the end?
dy.
dy over dx. And then, Vincent, any constant derivative is always 0. Okay, so according to Algebra 1, I'm going to do two things at the same time. We're going to subtract 2x on both sides and divide it by who? 2y. So we have dy over dx is equal to minus 2x over 2y. What is on the top and the bottom of my fraction that I can eliminate? 2's. So we know every slope function for any circles is always negative x over y. So you might want to write this down somewhere. This is the slope function of any circle. No matter where the center, no matter what the radius, because really in the end it's going to cancel out on the top and the bottom. So do we write always a slope function of the circle? Okay. But how many times were we supposed to derive this? Twice. So here I go. I'm going to derive this with respect to x. That's our second derivative. So I'm going to write on here, my second derivative notation is d squared y over dx squared. And I know some people are going to be like, what just happened? There's 2 x's and 2 d's. It doesn't matter. We didn't make that up. Okay, so now I have negative x over y. Isn't that quotient rule? Yep, let's apply the quotient rule. The quotient rule says everything on the bottom, all what? Squared, good. And then the quotient rule says derive the top. So when I derive the top right here, Santiago, what do I get? Negative 1. And then I keep the bottom. What was our operation separating the two chunks? Minus. And then we keep the bottom, or we keep the top, I mean. And then when I derive the bottom, 1y derivative is what? 1, and I need dy over dx. And if I want everything in terms of x and y, something is wrong here. I need to get rid of this by plugging in this guy over here, right? Let's plug it in. So I have, that's going to give me negative y. I think I want to go ahead and put plus x. And our dy over dx was negative x over y, all over y squared. Can I further simplify this if I want it? But you don't have to. I think I'm happy right here.